So hydraulic systems or pneumatic are systems where you pump liquid, and the liquid is used to move stuff. You have layered systems like hydrostatic, aerostatic stuff, and all these systems have a couple advantages over just having a motor to move stuff directly. One of the advantages is you can just have one powerful motor to give you really the strength and raw power at the base of your device. This means that if you have a complicated arm or some other complicated architecture, you can make it so that you can put all the weight of this giant motor on the bottom and make the arm a lot smaller, skinnier, so it can move faster. It's more adaptable. It can fit in smaller spaces. The whole thing can be more stable. It can lift more weight because it has less of its own weight. It might give you more repairability. That's one huge advantage. Another is that a more powerful is that instead of having individual little motors, you might need to still have some motors to control valves and stuff. Having one big powerful motor on the base means you can up the power in ways that a bunch of small motors can't, and you can just invest in one powerful motor. And if you have mobile joints, let's say you have 3 joints, instead of having to figure out how to make each joint, having a joint that's 1 horsepower, 2 horsepower, and 3 horsepower, you can make that trade-off. Sorry, each joint being 1 horsepower, you can make that trade-off less and have one giant motor that's 3 horsepower, and use that to power all the joints. And if you move this one joint at a time, you can get 3 horsepower worth of movement. Another one is that you can use it to control pressure in a system and speed and force a lot more accurately sometimes than you can with gears and stuff, and you can eliminate gearboxes and stuff like that. So eliminating gearboxes, huge advantage right there. You can also gears and other things like that can be complicated design because they're not flexible. So the piping and stuff, so you have to maybe make bulkier gears, or there are limitations in the shapes and the movement you can do constraints. Also, with hydrostatic and aerostatic things, and pneumatic and hydraulic, you can make it curve more and bend more. So a ton of advantages to all these systems. However, there's some major downsides. And one major downside that occurs is that if you pump, I forgot to say, is that if you close off a valve, you can just keep a pressurized and stiff or de-stiffen it and make the whole thing flexible and wobbly. But one major downside is that when you're pumping all this liquid and you're bending and stuff, you might lose a lot of energy due to friction, or it might become too rigid. And the more power and stuff you pump into the system, the harder it is to do all of this stuff. So if you have a tube going to 4 joints, for example, and you want to put a lot of power into it, you're pumping a lot of liquid, you might be able to move the end joint using that liquid, but it's also going to affect the movement of all the other ones as it stiffens up with all that pressure. So how do you make a tube that can carry a lot of liquid with a lot of pressure that's also very bendable and flexible and smoothly moves and adapts? Well, that's a challenge I'm going to present maybe a solution to right around here. And that is, let's say we have 2 ones with liquid moving. And this moving liquid is what we use to power everything. It could also be air, but liquid's more viscous, has higher density, and has better flow properties. And the idea I have here is that one tube, let's say it's going up, and there's another tube right next to it that's going down. In between, I put a barrier, and in this barrier, I actually have one-way valves. And one-way valve will let the water into a surface, into the one of the other tubes, so let's say from up tube to down tube. Another one-way valve lets it from one tube to other one, down to up, let's say. And alternate between the ones, so it's one goes one direction, one valve, the another direction, back and forth along the whole thing. Well, during the current near the surface, this creates a little bit of vortices, like spirals of circulating water that goes through. And these spirals of circulating water with the valves actually can make the water flow more smoothly, even when it's straight and with less friction, less loss, because they can act, if they're small enough on the right scale, act as little rollers, almost kind of like that, kind of let the waters roll and flow, less friction on the side walls. Well, now we have this. If we put if we bend this tube, what happens is these vortices then can interact and interfere with each other to make bigger vortices on one side, or vortices that are more oval or even triangular and stuff like that, that smooth out the transition and also release some of the pressure into the other container to the other side while keeping the whole overall flow of the system constant. So if one side gets more compressed, some of that liquid will go out into the other side quickly, but then the flow suction will suck it back up and back and forth in a vortice, in a new vortice that smooths out the transition, but still with minimal amount of energy loss, because you're not just pressing water from one side to another side. You're having it with a vortice, and it also can bend both ways, because a vortice is taking in water from one side and also taking in water from that same side. It's a vortex. It returns water from it takes back into the other side. This would allow it to deliver. Now, from all these little tubes, that doesn't mean because we're not stiffening up anything. Here, this really does not deliver the actual turn or movement. Then you need valves and stuff and side branches to do that. To further along how to make this more efficient, what we can do is something else, and that is we could have a collection of these tubes, each connected like this, that are all parallel. And then you can have, and if you make them the right dimensions, you can have a lot of vortices that add up and interfere in just the right way. You can also make these vortices interfere and stuff like that makes bending easier in one way compared to another way, depending on the size of the vortices, the number of gates and stuff like that. So you can even customize the flexibility and when it fluxes under what conditions. You could even have valves, all these little micro valves, become more or less flexible, easy to open up, or just open up totally under electrical stimuli or light, or under certain pressure, it seems. So a bunch of customization here. And then you could also design the branching network, how it branches off for power in all sorts of cool ways, using now better design tech from like AI and stuff like that. And have a bunch of smaller branches that can deliver a lot of power, and these vortices actually can give you more flow power than normal one, because they move water faster and they're more of a continuous thing with less power loss. Another thing you could do to make this whole thing more efficient is you could have each of these tubes also be pumps themselves by having bands that constrict and deconstrict and send a pulse of water throughout the thing, which you can also use to deliver, get rid of some of the power loss too. By keeping it moving smoothly or making it more adaptable with stiffness. So you could get a lot of advances. And another thing, let's just keep on adding on stuff, is this liquid pumping through it can also act as the coolant for the whole system. Coolant for the whole system. It can also act as a protective liquid to pieces if it gets cut or something. So in like an artificial skin, that if it gets cut or something, it helps. Bunch of things we could do there, and we could even if we, and because this is not a motor with fancy different mechanical parts and stuff like that and metals, you could 3D print this along making out of a plastic or something like that, and you could 3D print with other plastics. Now the reason why then you could have the motor just on the base. The putting metal and plastic together is a lot harder, impossible because they just have such a high different melting points, making the whole thing much more likely to interfere altogether if you try to do both at the same time. Well, this was just some quick ideas I had. Thank you very much for listening. Please like and subscribe. It really helps stand out. I'm trying to reach 1,000 subscribers in a year, 4,000 watches, which is really hard, really help I think can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave in the comment section below. Again, thank you very much. Goodbye.